Am I audible? Yeah. Hi, I'm Rishabh. I'm part of the RT Pilot dev team. Apologies in advance. I don't know why the screen is so yellow. It's not like that on my screen, but it's fine. I don't have a lot of videos. It's just mostly text. So I'll quickly begin my really short presentation on EKF source selection enhancements that I've been working on the past few months. Initially, I didn't have this slide on the existing source selection functionality that we have inside EKF, but I noticed there's a lot of confusion on how this stuff works. So I'll spend a few minutes explaining what we have currently, and then all the new flexibility that I've added the past few months. And then there are a bunch of other EKF fixes, mostly around visual odometry and non-GPS stuff that I've been working on, and all of that. Most of it is already merged. So I'll discuss some of those changes, and then the planned stuff that I have for the future. Yeah, so that's the outline. So starting with the existing features that we have inside EKF regarding source selection. So most of you would know that for most flight controllers with multiple IMUs, we actually have multiple EKFs that run parallel inside the flight controller. And we call them lane or core. Lanes and cores are basically interchangeable. They mean the same thing. Inside the code, we tend to use the word core, but the user-facing stuff is usually called lanes, but they mean the same. And for each IMU, there's an independent EKF that we instantiate. So for a flight controller like a cube orange with 3 IMUs, we'll have 3 separate EKFs that we'd instantiate. And which sensors those EKFs use is governed by these parameters called EK3 source 1, source 2 set of parameters. So you'd notice EK3 source 1 pos XY, which is the horizontal position sensor that the EK3 would use. Typically GPS or something like that would be set here, and then velocity and vertical position and so forth. And we have these three different set of parameters. One's the source 1, second's the source 2, and then there's a source 3. And then the common misconception is that the primary sensor is source 1, but then if you were to set something to source 2, the EKF would magically use it, or there's some clever math behind that the EKF would automatically jump to it, or if there's something like a lane switch that's happening, EKF is all of a sudden using the source 2 set of parameters to navigate. But that's not really true. The only way that the EKF would go, the EK3 would go out of the source 1 set of parameters is if you were to switch manually, if you were to do something manually. So the way that we switch between these source parameters is either through a RC options, RC switch. So if you have a RC remote control, and if you set RC options to one of the switches, so you could switch between source 1, source 2, source 3, or a Lua script to do it autonomously. We have a bunch of Lua scripts in the examples directory that already make use of this feature, or through ground control station or PyMavLink or something like that. So if you're not doing this, if you're not doing one of these 3 things, source 2 and source 3 parameters actually never really do anything. They're just sitting there. So hopefully that clarifies some of the things regarding the source parameters. And I have a little diagram here that explains it more. So cube orange, 3 IMUs, 3 EKF lanes, so just 3 parallel EKFs running all together. And you have the source 1 parameter that's possibly a GPS, source 2 parameter that's probably possibly set to using external navigation, source 3 parameter possibly set to maybe an external beacon system, and you have a transmitter there, and you can control your setup so that all the 3 lanes are using one of these 3 sources, right? And you can switch manually between them. But the important thing to note is that all 3 EKFs are using the exact same set of sensors. Yeah, so moving on to the work that I've actually done and the motivation behind it. If you have a setup that isn't just a GPS, say you have GPS, you have optical flow sensors, you have an external navigation kind of system working, how do you know which sensor you want to use? Right? And typically, an extended Kalman filter is a really good choice for that sort of things because you can get statistics, you can get some sort of metrics as to which sensor the filter thinks is the best to use. And we don't have that functionality in RD-Pilot, we didn't have that functionality in RD-Pilot because all the lanes were using the same set of sensors. And there was this interesting project that I was working on where we were trying to integrate this really new sensor, the non-GPS sensor, the computer vision based sensor. And what I would notice is that 9 out of 10 flights were fine, but every now and then we would have all the states diverge like crazy. And unfortunately, I couldn't bring the video, but these graphs are basically one of those states diverging like crazy. And if you see the drone, it's basically like a bullet. And it's really terrifying. And that's when I decided that we need to do something better. We can't just have all the EKFs using the exact same sensor. And so now we have this new feature called a source per lane. And it's hidden behind this EK3 source options bit. So if you enable this third bit, it does something different. And this has already been merged to master, so it'll be part of the RD-Pilot 4.7 release. And so what it does is that you have your standard setup of a flight controller with multiple IMUs, and you have multiple lanes. But now if this bit is set, the first lane would use the source 1 set of parameters, the second lane would use the source 2 set of parameters, and the third lane would use the source 3 set of parameters. So now all of a sudden, inside the flight controller, you have 3 different EKFs with 3 different set of sensors potentially being used, which I think is adding a lot more flexibility. And so you could monitor the innovations, you can monitor the covariances and stuff like that, and try and figure out which sensor set you really want to use. And so you have a lot more flexibility that way. Any questions so far? I do have a very, very short time slot, so I don't know if I should. Okay, go ahead. I think the max is 3. I could be wrong, but that's certainly something I'm looking into, and that's some of that is I'm discussing in a later slide on future planned work. The key problem is that the lane is linked to an IMU, and so if you have an IMU, you have a lane, right? And since something like Cube has three IMUs, you have 3 lanes, and that's why the number 3 is so commonly thrown. But I want to separate that, and so that you can have multiple lanes with the same IMU. But I'm talking about that a little bit in the next slide. Any other questions so far? Okay. So the other concept that we have inside EKF and the lanes is lane switching. I think most of you would have sometime or the other on the mission planner screen seen a lane switch warning pop up somewhere or the other. And that's basically when your primary lane is not being used anymore, and the vehicle decides that it wants to switch to a different lane, a different IMU, a different core. So the only sort of control that we get right now in RDCopter 4.6 is that the user gets to set a primary lane, which is done by this parameter called EK3 primary. And the other flexibility that you have is that you can decide which IMUs you really want to use. So that's done by this parameter called EK3 IMU mask, right? So you can decide that I don't want to use a certain IMU, or I want to use this IMU. But other than that, you really don't have much flexibility when it gets to when we talk about lane switching. And switching to a new lane is automatic. It's based on a score. So I won't talk too much about this, but it's basically based on a score that we give to each lane. And if for whatever reason the score for one is higher than the other by some margin, which is configurable, then we'd switch to a new lane. And the other is if the vehicle is trying to avoid going into an EKF failsafe sort of situation, so it'll try to switch to a new lane. But what's important is that it just happens, and there's not much flexibility around it. So now that you have a little bit more flexibility there, and so hidden behind EK3 option second bit is something called as manual lane switching, and this is again merged into RD Pilot, so it'll be available in Copter or RD Pilot 4.7. And what it does is that it stops the existing lane switching logic altogether, and it sets the primary into whatever is set as EK3 primary. So you could have a Lua script that changes EK3 primary, and it'll change the active primary lane mid-flight. So that's the other flexibility that we have now with lane switching. Any questions? Okay. So that was it regarding the lane switching and source selection flexibilities that we have added. But there's a bunch more work that I've done in the past few months regarding EKF, just general EKF enhancements. These are requests that have been coming from partners, that have been coming from discussion forums, or that I've just noticed while I was working in this area. And the first one is pretty interesting. So if you're using an external navigation sensor, you're feeding data through the visual odometry library, and you didn't have EK3 source Z set to external nav, and you had source XY velocity set to external navigation, it was still fusing in the vertical velocity, which would cause a nasty crash if the vertical velocity was not correct. So that's fixed now. So you don't necessarily need to pass a vertical velocity just if you want to have the horizontal velocity being fused. That's fixed. The other thing was that if you had a GPS and an external navigation sensor working together, we weren't using the correct variances. And it was actually using the variances of the GPS and not the external navigation variances that we are passing in. So that's fixed now. And then there were some other issues, other similar issues with some of the GPS stuff getting mixed in with external navigation stuff. So I've fixed a bunch of those. Then the other enhancement that we have done is that there are cases where the EKF decides that if you have multiple compasses, it wants to switch to a second compass because it thinks the first compass or the primary compass is unhealthy. For the remainder of the flight, it would continue to use the or for the remainder of till a reboot, it would continue to use the newly switched over compass, and for some reasons that could be dangerous. So now we have this new feature that's merged inside that once on landing and once we disarm, we go back to the default primary compass, and we don't keep using the secondary compass. The other feature that I'm working on is that there's some logging around EKF cores that only applies to primary EKF core and doesn't really log the secondary or the tertiary EKF cores. So I have a PR there that's not merged yet, but I'm hoping that'll be merged soon, where every single thing for every single core is logged, so that it just helps in debugging. And then there's a bit of a controversial PR here that we have merged now, where we were fusing in all the velocity sources that you had mentioned in the EKF source parameters. For example, if you had GPS and an optical flow, by default we were fusing all of those velocities inside the EKF. So this was causing problems because most users either want a GPS or an optical flow sensor to work, and they don't really want both of them to be fused in by default. And so folks like myself and Randy and others, we had to constantly tell people to switch off this bit that was switched on by default. And so we decided it's just safer that this is now off by default. And if you really want both of these velocity sources being fused in, you can switch it back on. And then there's some non-functional enhancements where I've tried to document and clean up the post-well fusion code and some other documentation enhancements so that hopefully the EKF code, at least the parts that I'm working on, are more readable. And finally, some recommendations. If you're using an external navigation solution, especially if you're using it with a GPS, I would recommend that before you upgrade to master, maybe just grab a replay log from 4.6 and pass it through 4.7. Just make sure everything's working fine. There's some things in there that we have changed that potentially change how things were working, and you might be surprised that things might be working better or worse. So it's just better if you would run your logs through a replay before actually flying. And replay logs are always a good chance to test some of these enhancements safely without actually risking your vehicle. Finally, some of the future work that I have planned. I was hoping I would get through at least some of these during the time we have before the conference as like a hacking sort of a thing. I did get the first one almost done. So I want better access to the individual cores in terms of the health of each cores in Lua. So imagine a Lua script being able to do lane switch, but like in a much more informed way. So that's coming. I've actually managed to replicate the existing lane switching logic completely in a Lua script, and that PR is coming. So that one's almost done. I also want to rework some of the existing lane switching logic that we have. This is the one that I've not made any headwinds with. It's really complicated. And the reason I want to rework the existing lane switching logic is because most of the lane switches that I see on a day-to-day basis, they can be accounted for by just tiny timing differences between individual cores. So the cores don't really run all at the same time. And if one of the cores has a marginal increase in its score for a really, really short time, you notice that there's a lane switch, and it really doesn't make a difference. And it just sometimes scares the users at best. So I'd like to fix that, but I need suggestions from other devs on how that would really come about. And then some of the other things that I want to do is I want to fuse multiple position sources together, so we can fuse multiple velocity sources, but we can't fuse multiple position sources yet. So that is coming. I have a PR for that. And the last thing that I really want to do is what Josh was talking about, is move away from the core being so linked to individual IMUs. So if you have a flight control that only has one IMU, I still want to be able to run multiple EKFs on it. Unfortunately, that is a little bit more complicated than I thought. I thought I'd get this work done before the conference starts, but no, that's sadly not true, and it'll take some more time. But hopefully next year, I have some of this done, and I could give a talk on that. But if you're interested in any of this work, feel free to talk to me, and maybe we could set up some replay sessions, and I could show you how some of this stuff works, and if it'll be useful to you. That's it. Any questions?
Hey, so if we have, say, for example, two lanes and they're independent, one of them is using like GPS and one is using optical flow, the optical flow one's going to end up with a lot of drift. What happens if you start switching between those two lanes?
Good question. So it really depends. We shouldn't be I would say in a situation like that, maybe it's the best option to actually set that EK3 options so that we disable the automatic lane switching. And you have to come up with your own Lua script to come up with a good way of, when you really want to switch between those two lanes. I have a feeling that the existing lane switching logic might just work, but it's something that I haven't tried yet. So most of this work was actually done for external nav plus GPS kind of vehicle, right? Anything else? No, I've thought about it. I have a couple of PRs that try to do something smart, but no, I think that's not something I want to do just yet. There's a bunch of like just non-GPS kind of things, certain assumptions that we make that are so linked to GPS that I want to get rid of first before moving into that direction.
Okay, thank you very much, Rishabh. That's all the time we've got for now. Round of applause again, please.